Applications of trig functions, solving a right triangle. First, I'd like to specify how it is that I labeled this triangle. Notice that I labeled the hypotenuse with the lowercase c. And then what I did was I labeled the two legs A and B. It doesn't really matter which one I labeled as A or B. But a convention commonly used in math is that you then label the angles that are across from those sides using the uppercase version of the letter. So across from side B would be angle B, across from side C would be angle C, and so on. Our problem here says suppose that angle A is 35 degrees and the length of side C is 9.3. Solve the triangle. What we mean by solving the triangle is coming up with all the unknown sides and angles. Now, clearly there are some things we know here. Let's fill them in. We know that angle A is 35 degrees, and we know that the side of C is 9.3. Of course, we also know what angle C is. It's a right angle, so it is 90 degrees. So we have one angle and two sides which are unknown to us. There are many ways to start these problems, and in fact there's often many ways to do them. I'll point that out more as we go along. But to get started, let me just rather randomly decide to try to find the length of side A. Now here's what you do. This line here just means blank space for the moment, and we're going to be filling that in. We're going to be doing some trig function on our known angle 35 degrees. It'll be sine, cosine, or tangent. And that trig function we know will equal a fraction. We know from SOHCAHTOA. Here's what we do. We want to set up a fraction that involves what we're trying to determine, which is A, and we also want to involve the side that we know, which happens to be C, 9.3. Now think about how those would be labeled. A would be opposite of 35 and C would be the hypotenuse. Now opposite and hypotenuse, that should suggest to you the sine function. Sine equals the opposite over the hypotenuse, which is A over 9.3. And that's the equation we're going to solve. Turns out it would be pretty simple to do. Let me erase this in the middle because it was just for illustration. So this is our equation. The way we'd solve it would be to clear the fraction. We'd multiply both sides by 9.3. That would give us 9.3 sine of 35 on the left, and on the right, multiplying by 9.3 would give A. Notice this is just a calculator problem now. Before you use your calculator, you want to make sure it's in degree settings. And since the side C was given to 1 decimal place, I'm going to round A to 1 decimal place also. I got 5.3 for that. So there we are. We now know side A. Let's do a similar analysis to come up with side B. I'm going to start out the same way. I'll have some unknown trig function of 35 degrees equals some fraction. Very similar to the previous part. Now when we're looking at 35, B would be the adjacent. And adjacent over C hypotenuse, that is a cosine function. So cosine of 35 equals the adjacent, which is B, over the hypotenuse, which is 9.3. And just like the last problem, we can multiply both sides by 9.3 in order to clear that fraction. Feeding that into a calculator in degree setting, rounding to 1 decimal place, would give us a 7.6 for that side. And now we know all three sides. What don't we know? Well, it looks like at this point at least, we have not determined the value of side B. So let's get that. We don't really need trig for that. We know that with a right triangle, for that matter, any triangle, the angles add up to 180 degrees, and we already know one's 90 and one's 35. So to get angle B, we could take 180 degrees minus the sum of the 90 and the 35. 90 and 35 give 125. So B would be equal to 55 degrees. And we're done. We've solved this right triangle. We're going to do one more example in this lesson, but we're going to have a little fun and do a more practical situation. Trigonometry was originally developed specifically for doing measurements which were hard to get at by themselves. So for instance here, I have a tower, looks suspiciously like the Eiffel Tower. And suppose we started out underneath the tower and we paced out a distance of 54 feet. And then we turned and we looked up. We saw that we had to look up 43 degrees to see the very tip top of the tower there. That's called an angle of elevation. If you were standing like on a mountaintop and looking down, you would call it instead an angle of depression. Well, we're going to do this problem very much like the problem on the previous page, except we won't have as much work. This height here that we want to discover, h, would just be one of the sides of what you could visualize as being a triangle. And so we want some trig function of 43 degrees rather, equals a fraction. Now let's see what fraction we can form. H would be opposite of that angle and 54 would be adjacent to it. So what's opposite and adjacent? Well, it sounds like tangent, doesn't it? Tangent is the opposite, which is h, over the adjacent, which is 54. Hey, we can go and clear the fraction. 54 tangent 43 will equal h. I know I'm reminding you for like the third time in this lesson, but make sure you're in the right mode. A lot of people have their calculators in radian mode. Switch it to degree. And what I got, and I rounded it to a single decimal place, got 50.4. The units would be feet. Okay, so lots of applications that you can do solving a right triangle. Be signing out now. Good luck.